Organic Chemistry 1. It's Organic Chemistry 1. Welcome everyone. Welcome. So it's going to be a very long, long day where I'll be, explaining the concepts of organic chemistry. Welcome. If you can hear me, please drop in the comment section. So this is introduction to organic chemistry. Introduction to organic chemistry. Good. If you can hear me, drop. Yeah, yes, I can hear you loud and clear. Fantastic. Juliet, how are you? So this is one of the major topics in your chemistry. Good evening. Oh, amazing. I can hear you. Good. Today will be a very long day, guys. So hold your pen, hold your books. Good evening, sir. How are you? Well done. Tilda, how are you? Fine girl. What's up? How are you? Hope you are fine. How is reading going? So yeah, Tilda, Juliet, welcome. Oh, good. Hope you guys are doing well. So the exam is fast approaching, and today will be a very long day actually, because I'm going to discuss organic chemistry 1, which are the alkanes, alkynes. If possible, we get to benzene. Okay, so we know that we are done with organic chemistry 1. So it's a major topic. People don't know it, and that's why we have to do it. So let's get to work. Now, introduction to organic chemistry, right? And before that, what is organic chemistry itself? What is organic chemistry itself? What is organic chemistry? Oh, no. Don't forget that it's a branch of chemistry on its own. Is a branch of chemistry. Just like we have other branches like, electrochemistry, thermochemistry, industrial chemistry, inorganic chemistry. So this organic chemistry is a branch of chemistry on its own. Now, but then we have to understand that this organic chemistry, they will produce what we call organic compounds. Okay, so now we want to talk about what is an organic compound. So I'll give you a brief history about it, then we'll get to work. Now, if you know this word organic, it means living. Please, if at any point you cannot hear me, let me know, please, so that I don't talk to myself. It means living. This organic, the word organic means what? Living. Now, which means living here means any compound you can get from plants and animal is what we... Who is this? Okay, so can you guys hear me? Can you guys hear me? So living, which means they are compound from plants and animal, because that's when we can say okay, yes, are good. That's when we can say organic compounds. So that was the first statement. Okay, now, but this is wrong, because something happened. You see what happened now. So in 1927, there's a particular scientist called Frederick Wohler. This is a JAMB question. No? Frederick Wohler, who was the first scientist, was the first person to discover the first organic compound in the laboratory. Now, what is important is that word, in the laboratory. Now, I mean, Shebi, you said organic are compounds. Yes, they are right, because the word organic means living. You said they are compound from plant and animal. But why is it that this man now went ahead to discover what we call Frederick Wohler? Please note it, too. It's a JAMB question. He was the first person to discover the first organic compound, and that compound is urea. So it's a JAMB question. What is the first organic compound to be synthesized in the laboratory? Urea. This is the compound of urea. I will still, it's an amide. Anyways, it's an amide, but you might not know that for now. So this is a compound. So he was the first man to discover the first organic compound. Then the definition of organic chemistry, organic compound changed. I mean, if we cannot discover it in the lab, why should we say it is from living organism alone? So it was this time that this man made this thing happen. So we now redefine that definition. Okay, we now redefine that definition. So we redefine it and say organic compounds. We redefine it and say organic compounds are compound of carbon and its derivatives, with the exception of carbon 4 oxide, which is CO2, carbon 2 oxide, which is CO, and triazocarbonate, which is CO3 2 minus. Now, which means any compound that is this, like this one, CO2, CO, and this, they are not organic compounds. They are inorganic. But yes, they are compound of carbon. They are compound of carbon, but they are not organic. So they are inorganic compounds. So any compound of carbon and its derivatives, with the exception of CO2, CO, and triazocarbonate, are termed organic compounds. Okay, so this was the reaction that happened. Anyways, for knowledge's sake, ammonium cyanate, that's what the man used. Ammonium cyanate. Then it's realized that this ammonium cyanate, this is just for knowledge's sake. Ammonium cyanate, this is what the man used. Then he produced NH2 into 2CO, which is urea. So the first organic compound to be synthesized is urea. Okay, so this is a brief story about the whole thing. So this is a JAMB question. First organic compound to be synthesized. Juliet, what compound to be synthesized? Are you with me? Are you guys with me? Synthesized in the laboratory. Are you guys with me? NH2CO. No, it is NH2. Look at it. You know, C, I'm still going there anyways. It's because I've not started the proper organic. Now, you know, C must always be bonded to four valency, like this, 4 bonds. So O, then this NH2 will be here, then another NH2 will be here. So this is urea. This, can you see? Carbon must always have 4 valency. So can you see 1, 2, 3, 4? Please, sir, I'm just joining. Please turn the book. No, you will come back to listen to it. You come back to listen to watch it. There's no time now because we have a lot to cover. Okay, but because you've not moved fast, so you can just screenshot. But don't forget, urea is the first organic compound to be synthesized in the laboratory. Just screenshot. Maya, screenshot because you have not moved far. Screenshot. Please, you guys should be screenshotting. There's no time, or you can come back to listen to it, so that we can move fast. Okay, now, so you must know that carbon must always have 4 valency, just like you can see 1, 2, 3, 4. So oxygen must be 2. That's why it is this, then this. So this is what we call urea. Okay, now I've told you the JAMB question. Now let's now go back to the table, to what we need to know. So since we already know that, then we can have a proper sketch on what we need to do. So now don't forget that we have organic compound. Now this organic compound can be divided into two. We have the hydrocarbons. This is what we'll be focusing on today, and the non-hydrocarbons. Now this is so easy because as you can see the word hydrocarbon, it means this compound contain hydrogen and carbon only, just like you can see, hydrogen, carbon only, right? That means these ones are the compound that contain carbon and hydrogen and other elements. Like what? It can contain nitrogen, it can contain sulfur, it can contain oxygen, it can contain anything, but they are not carbon and hydrogen only. Okay, so if I ask you, if you see C2H2, now that is why there is a statement that states all organic compounds are hydrocarbon, but all hydrocarbon are organic compound, but not all organic compound are hydrocarbon, because there are some that are non-hydrocarbon. So if I ask you this question now, this guy, yes, is an organic compound and is also an hydrocarbon because it only contains hydrogen and carbon, but it is not non-hydrocarbon here, because non-hydrocarbon must contain other elements like nitrogen, sulfur, oxygen, etc. Okay, so please take note of this. Now this is our major focus, right? Now this guy can also be divided into two. It can also be divided into two. We can have what we call saturated hydrocarbon and unsaturated hydrocarbon. Now when it means saturated, it means that all these bonds are fully filled with the bonds. You see it now. So under saturated, they are just one, and this saturated can be what we call aliphatic chain, right? Now this aliphatic will just mean they can be straight chain or they can be branch chain. Okay, they can be straight chain, they can be branch chain. Now the example here is now what we call the alkanes. Please take note of alkanes. These are the ones that have what we call single bonds. You will see it now. So like, let's say we have something like this: C H H H H. Now you can see that they all have single bond. That is why the word saturated, that is, the bonds are saturated, right? They are all, because carbon normally should have what we call, carbon should have four always. That is the property. Carbon should have four always. Okay, carbon should have four. 1, 2, 3, 4. So please take note, the shape of like methane now is tetrahedron. You should have seen the question before, or tetrahedron. This is what they mean. Can you see when I draw it like this, it looks like tetrahedron. This is a JAMB question. The shape of methane is tetrahedron. Okay, take note of that. So these are alkanes. Okay, now they have a general formula of Cn. Don't worry, we'll still do it properly. CnH2n plus 2. This is their general formula. This is another JAMB question. Just coming. You're welcome. We just started. We have not gone. Just take note of this. Hydrocarbons, non-hydrocarbons, like organic compound divided into two. It can be saturated, unsaturated. Saturated means they are all filled. Right? Unsaturated means they are not all filled. Like there's still a pi bond that can be broken. Now, what are the examples? We can have what we call the aliphatic, and we can have what we call the aromatic. Now, the aromatic are the arenes. A very good example is benzene, which is C6H6. That's the general formula of benzene. And I will still talk about who discovered this guy. But in case I don't talk about it, August Kekulé was the man that discovered this guy, benzene. August Kekulé in 1865. Now, what is now the aliphatic example that we have here? It is the alkenes and alkynes. So these are the double bonds, right? These are the triple bonds. Just take note of that. Don't worry about yourself. Are you guys following? Are you still here? We'll still pick them one by one. So, but do you guys understand up to this point? Alkynes are the triple bonds, alkenes are the double bonds, alkane are the single bonds. Alkanes are the single bonds. Okay, Alkanes are the single bonds. Alkanes are the single bonds. Are you with me? Okay, yes, sir. Alkanes are the single bonds. Yes, sir. Good, good. Now, good, good. So there's something that JAMB used to ask on these guys. There's something that JAMB used to ask. Just take note that. Okay, let me just put. So you can screenshot. I'm going moving. Will the live be saved? Will I be able to come back? Yes, definitely, definitely. I will save it. You'll be able to come back. You'll be able to come back. So I already talked about the shape of methane. Tetrahedra is a JAMB question. Now another thing you must know is that these guys, they are sp3 hybridized. Don't worry about how they got sp3. Just take note. They are sp3 hybridized. This is another JAMB question. Alkene, they are in the middle. So they are sp2. They are sp2. While alkynes, they are the last. They are sp. So this is a JAMB question. If you have read, you should have seen this. So alkane, sp3. In, they are in the middle, sp2. Then alkyne, they are the sp. So basically, you should know that alkynes are more reactive than alkenes, and alkenes are more reactive than alkanes. Okay, I've seen it exactly. If you have read, you should have seen it. There's no way. And another thing that you must note is that, let me just let me write it in another place. So screenshot if you have not. Screenshot if you have not. Now another thing you must note is that alkanes, another name for them is called paraffins. Now if you look at this word, it has two meanings: para and affinity. Affinity. And you know that when you talk about affinity means like. But when you now para for that affinity, it means you have little. You don't even like it. You have that, very popular question. Good. Sir, please, what is the shape of sp2 is trigonal planar. sp2 is trigonal planar. sp2 is trigonal planar. So now para affinity, it means, so you dey para for the affinity. It means, so para affinity means little affinity. Sir, would I be able to watch it? Yes. Little affinity. Para affinity means what? Little affinity. That means these guys don't like to react. They can't react like that because they have little affinity. So please take note. Please take note of that. Now another thing that you must also take note is that alkenes they are called olefins. Olefins, what olefin means? Moderately reactive. Olefins means moderately reactive. And the last one is what? Is alkynes. Alkynes, which means what? Which we also call acetylene. Alkynes, that is the triple bond O. They are called acetylene. The double bonds are called olefin. The single bonds are called paraffins. So para means little. You dey para for the affinity. So you have little affinity. Olefin means moderately reactive. Acetylene, another name for alkynes. Okay. Now you have to also note that, do you get up to this point? Before I move on, do you guys get it? Zacchaeus, do you guys get it? Precious, before I move on, do you guys get up to this point? Please take note of the, yes sir, Queen. Yeah, good. Now just one person. I've seen one person. Wait again. Yes, good. Tilda, do you get it? Good. John, good. Fantastic. James, which side? Which part? You can. I think you have to watch it again. You are the only person. Which side? There's no time actually, but I think you just joined, so that's why. Alkene. I've not said moderate. Come again from alkene. I didn't say anything about alkene now. Alkene means olefins, moderately reactive. We've not gone into the actual thing. I'm just trying to explain. The other name is olefin, which means moderately reactive. Another name for alkyne is acetylene. Another name for alkane is para affinity, little affinity. I've not, please sir, what is the shape of sp? I've already said the shape of sp2, trigonal planar, sp2. Not all of them though, but majority of them are trigonal planar. I've already said it now. Trigonal planar. The shape of sp3 is tetrahedra. This is another, please hope you guys are writing. Oh, these things are very, very important. And the shape of sp is linear. So just note this. So sp2 is trigonal planar, sp3 is tetrahedra, I will tell you, look at, don't worry, when we begin to talk about them, you see why they are linear. But just note that this guy is linear. Look at it, for instance, C triple bond C H H. Can you see? It is on a straight line, so it is linear. So the angle of this guy is 180 degrees because it is linear. Can you see? But this is tetrahedra. I already gave an example. But sir, they do ask for the, yeah, that's what SP is linear. Yeah, that's what I'm trying to say. So this is tetrahedra. So the angle of tetrahedra is 109.5 degrees. That is the angle of sp3, 109.5. The angle of sp is linear. Can you see it's linear? So it's 180 degrees. The shape is linear, the angle is 180. While trigonal planar is 120 degrees. So 120 for trigonal planar, tetrahedra 109.5 degree, and linear 180, just like angle on a straight line. Linear. So are we good? Can we move on? So these are just, general stuff that we are talking about, okay? So that we can we move on? Oh, are we good? Can we move on? Good. You can screenshot if you want to. So now let's go to general, or what we call characteristics. Can you move your sheet upward because of comment? Can you move your sheet upward because of comment? Which sheet? Okay, nothing now. It's not affecting anything. Please. So now characteristics of organic compounds. That is, when you see organic compounds, what can you talk about them? That's what it means. The first thing is that the first thing that you must know is that they are what? They are non-polar solvent. Sorry, they are non-polar. Hence, they dissolve in non-polar solvent. Let me give you a very good example. Just like petrol is an organic compound. Petrol cannot dissolve in water. So petrol is non-polar. It will only dissolve in a non-polar solvent. So that's why kerosene and petrol can mix, because they are both organic. So in this kind of thing, it is, this is non-polar, so they are alike. So it is unlike. Can you guys hear me? Can you guys hear me? Good. So the network seems bad. I'm back. Someone called me. I want to put my phone on do not disturb right now. I don't know. Should have done that since. Wait, I think if I put it on do not disturb, it will not affect my network now. I don't think it. Oh my god. I should have done this. So okay. I hope they won't come again. Yes, water is solar. Water is solar. Water, no, it won't affect your network. Don't worry, let's continue. Don't worry, I hope the person don't come here again. Water is polar. Kerosene cannot dissolve in water. Do you understand? That's the number one. Number two is that they are what? They are covalently bonded. Covalently bonded. You must know that. Are you starting afresh? Yes, you can watch back later. But I've started seeing my phone is always on do not disturb and my network is good. Okay. I think let me see if it's possible for me to put it on do not disturb right now. Let me see. I'm coming. Give me some minutes, please. I don't want anybody to call me. Do not disturb. Can't even see it yourself. Okay, let me search. DND. Okay, I'm coming. Please just take note of what you have been saying, please. Can you guys hear me now? Yes, all of them are covalently bonded. Can you guys hear me now? Can you guys hear me? Can you guys hear me now? Yes, they are covalent. Good. So I think I've achieved that. Let's go. I've achieved that. Now, number three. All of them are covalently bonded. So because they are covalently bonded, just like when we talk about ionic bond and covalent bond, you realize that because these guys are covalently bonded, so they generally have what we call low boiling and melting point because they are covalently bonded. Low boiling and melting point because they are covalently bonded. Unlike ionic bond, that they are what? They are electrovalent. Hence, they have high melting and boiling point. But because these guys are covalently bonded, they have low boiling and melting point. You must take note of this. They have low boiling and melting point. Okay. Number four, another characteristics of organic compounds, right? They have family. Can we still say that they are non-conductors? No, that's not conduct. It's not about, yes, of course, if they are non-polar, they will not conduct. But that's not what we are trying to say here. That might be under another thing. Since they are non-polar, they will not conduct. Do you get it? They cannot have ions. So they are not conductors. They are insulators, basically. But we are not talking about them being able to conduct. Family members are called homologous series. This is a JAMB question too. Homologous series. Just like if you are in a family, your brother, your sister, your elder brother, your junior brother, your elder sister, your junior sister, all of you are called homologous series. So just like we have alkanes and we have members of alkanes, so those members are called homologous series. And this is the JAMB question. And they differ by dash CH2. They differ by dash CH2. Don't worry, we'll still get there. They differ by dash CH2. Or what is the molecular mass of this? Carbon is 12. Hydrogen is 1. So 2 times 1. So it's equal to 14 gram per mole. You might not understand this one now, but if you have read, you should know this. But I will come back to this. But now, because I cannot talk about this without talking about the members themselves. So when I get to alkane, I will talk about it. So when I get to alkane, I will talk about it. So just take note of this. They differ by dash CH2. They differ by dash CH2. Take note of this. It's a JAMB question. They differ by dash CH2. Okay. Are you with me? So if you want to calculate the molar mass, you can say carbon is 12. 2 times 1, 2. So 12 plus 2 is 14. Are you with me, guys? Are you with me? Are you guys with me? Yes, sir. Good. 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 You guys are following. You guys are following. Okay, we already talked about. So another thing that you must know, that they are generally insoluble. They are insoluble in water. Just like we've talked about, they are insoluble in water. They are insoluble in water. You must take note of that. Of course, they are non-polar. You don't expect them to be soluble. They are insoluble in water. They cannot, just like I don't understand for, please. What is for? You will not understand now. Don't worry, you understand later. But just take note of this. When I will talk about it, when I get to alkane, I will talk about it properly. But just know that each member differ by dash CH2. It's a JAMB question. No? Or if you calculate the molecular mass of this, 12, carbon is 12, then 2 times 1, 14 gram per mole. I cannot explain here because I'm just talking about general characteristics of organic compounds. Do you understand? Okay. Number 6. You understand it when I get to alkanes. Okay, what do I want to say again? So I've talked about this insoluble and yes, the volatility is inversely proportional to boiling point. Now, volatility is how easily they can vaporize. Just like if you put petrol on the ground, you will not see it in few minutes because they can easily vaporize. So that's what I mean by volatility. And it's inversely proportional to what? Boiling point, right? That means the higher the boiling point, right, the lower the volatility. And the lower the boiling point, the higher the volatility. That means I can tell you now that methane are more volatile because methane is the first member. They are more volatile than butane. I can say butane are more volatile than octane because as we go down the group, the boiling point and melting point increases because their molecular mass increases. You understand? As we go down the members, we've not talked about this will make sense by the time we pick a family and we talk about it. But it's not making sense now because we not pick a family and talk about it. But just know that volatility is inversely proportional to boiling point. You will now begin to see that. That means boiling point, it deals with what? As we go with molecular formula, or molecular mass. Let me use mass. Molecular mass. So if the molar mass or molecular mass is higher, the boiling point will be higher. Okay, take note of this. This is another thing that you must take note. The last one that you must note as a characteristic of organic compound is that the present number 7, the presence of hydrogen bond is important for the increase in boiling point of some organic compound. E.g., you can say that ethanol now, for instance, ethanol is, let's say, CH3 CH2 OH. So it has hydrogen bond. Another very example is CH3 COOH. This alkanoic acid. You might not know that for now. Don't worry. I will still get it. But if you know, it's good. So they have hydrogen bonds in them. So it is also necessary for the increase in boiling point. You understand? So these are all the things we've talked about organic compounds. Okay, we talk about the general stuff that you should know about organic compounds, the characteristics. They are non-polar. They dissolve in they dissolve in non-polar like them, like alkane, like benzene, and like petrol in kerosene. Kerosene cannot dissolve in water like that. We talk quite. I don't understand. Okay, it's still that for. So now we've talked about quite a number of things. Now let's go back. Let's pick a member and talk about it. Let's pick a member and talk about it. Now, the first member we'll be picking is what we call the alkanes. The alkanes. This is ethanoic acid. They have to don't these are functional groups. You still get to know them. You still get to know them. Let's just pick one and talk about it. Okay, should I talk about functional groups now? Okay, let me just talk about functional groups, then homologous series. Functional group. What is a functional group? Let me just talk about functional group so that you'll be able to know what we mean by some things. Now, what's the functional group? Just like the way the word, they determine the function, Abi? Function. I like that word. So functional group are either bonds. They can be bonds. What do I mean by bonds? They can be single bond. They can be double bond. They can be triple bond. Or group of atoms that determine the chemical properties of a particular homologous series. This is the easiest thing I've seen, but people don't know it. Look at it. In your family, there is something that is common to all of you, that if they see it, they will know that this is Fafure family. If they see, they will say this is Juliet's family. If they see, they will say this is Tilda family. If they see, they will say this is my family. So that thing, either now in this case, it can be single bond. It can be maybe based on, if you see Ibadan people, based on their tribal mark, that is their functional group. Ibadan people, the tribal mark, sir, please, is it all alkane you're explaining now? No, I've not. I'm explaining functional group. I've never started alkane. So based on that future, you will know that this is your family. This is Victor's family. This is Shegun's family. So that means they can either be single bond or double bond, or just like if you see single bond, which family will you think of? If you see single bond in a compound, all true, which family will you think of? I want to say those that don't understand what I'm trying to say. Which family will you think of? If you see single bond, which family will you think of? You guys should be fast. Alkane. That means single bond is a feature of alkane that determine the what? The chemical properties. If you see double bond, you think of alkane. If you see triple bond, you think of alkyne, right? If you see OH, you think of alkanol. If you see COOH, you think of alkanoic acid. So that is what they say. So functional. So it determines the function. So are either atoms, bonds like this, or group of atoms that determine the chemical properties, just like tribal mark determines the chemical property of some family. So don't cram, okay? So e.g. single bond, double bond, triple bond, OH, don't worry, COOH, okay? So these are what we call functional groups. ETC. There are a lot of them, but these are just what we. So ETC. Now, let's now pick some functional groups that you must know that they are common. So let's say family, then functional group. Number one, the alkane. Why should, sir, please be screenshotting it, please, as I'm writing, and when I'm done, screenshot, please. Okay, there's no time. You can screenshot, please. Alkane, that means the functional group of alkane in this case is single bond. Just like we said, single bond. That's the functional group. Number two is alkenes. The functional group of alkene is double bond. Yes, you can write or you screenshot, either of the two. Whichever one works. Number 3, alkynes. The functional group of alkyne is triple bond, which is like this. So the next one is alkanol. Alkanol. The functional group of alkanol is OH, the hydroxy group. Number 5 is alkanal. Alkanal. The functional group is -CHO. CHO. This is what is responsible for the reducing ability of glucose. This alkanal group -CHO. This is the functional group. Number 6 is alkanone. Alkanone. The old name of this guy is ketones. The old name of this guy is ketones. The old name is ketones. The old name of alkana is aldehyde. Aldehyde. That's the old name of alkana. So the old name, they have old name, they have new recent name. So this one is ketones. Their functional group is RCOR. Okay, so it is CO here. That is the functional group of ketones. This one can mean alkyl groups. Don't worry, you might not know that now. Let me pick one, but just know the functional group as I'm saying it. CO. Number 7, another functional group you want to know is alkanoic acid. Alkanoic acid, which is what? RCOOH. Alkanoic acid. RCOOH. You want to take note of that. Number 8. Okay, these are functional. Number 8. Another thing you want to know is what we call amine. Amine, which is RNH2. RNH2. This is amine. There's another one we now call amide. Amide. Amide, which is RCONH2. This is amide. Wow, no wonder I did see RC. Yes. So can you see exactly? So this is amide. 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 CO is there with the NH2. Like this one, amide do not have. They don't have CO. Okay. Another thing that you must know is alkanoate. Alkanoate. This is what we call ester. 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 Esterification reaction. So it is RCOOR. See, it's there from this one. This is RCOOR. Alkanoic acid is RCOOH. So don't miss it. They are two different things. They are two different things. So RCOOR. So is a non fantastic guy. Yes. Do you see? Do we talk about it? It has N. Is not an hydrocarbon. This one is not an hydrocarbon. It's not an hydrocarbon. These are non-hydrocarbon. Non-hydrocarbon. We'll get there. Non-hydrocarbon. 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 So alkynes are hydrocarbon because they have carbon and hydrogen. Alkenes are hydrocarbon because they have carbon and hydrogen. Alkanes are hydrocarbon because they have carbon and hydrogen. Do you get that now? So since they have any other thing aside hydrogen and carbon, they are non-hydrocarbon like this. They are non-hydrocarbons. They are non-hydrocarbons. They are non-hydrocarbons. So please take note of these 10 functional groups that we talk about. There are other ones, but these are the major ones that they will ask you. Okay, that they will ask. Another one, the functional group that you must also know. That might not be necessary, sure. Just take note of these ones. Don't worry. These are the major ones that you should know. You can screenshot now because I'm moving to the next page. So we'll now pick one family and discuss it. Second family. But don't forget, our focus is on these first three. Our focus is on organic chemistry 1, which is hydrocarbon. Organic chemistry 1 is hydrocarbon. Chemistry 2 is non-hydrocarbons. So are you done with your screenshot? So we can move to the major meat of the matter. Is OH look at what you said. Is OH an hydrocarbon? Is OH an hydrocarbon? Where is the oxygen? Is it an, if it has O, is not an hydro. Hydro is from hydrogen. Carbon is from carbon. So hydrocarbon, just like the name. I've explained this thing now. Hydrocarbon. It just means hydrogen plus carbon. So where is oxygen here? So anything that has carbon and hydrogen like this, these are what we call hydrocarbon. Since it has OH, it's not an hydrocarbon. It's a non-hydrocarbon. So don't miss it. I've explained it before. Are you good? Juliet, are you good? Are you good? Are you good? Let's move on. Let's pick one member. And, are we good? Or are we good? Are we good? There's no time. There's a good screenshot if you want to screenshot and move. Only 2 persons replied though. I want to be sure I'm with everybody. Good. Good. Okay. Let's go to the first member. So we're talking about our go on, yes sir. We're talking about the first member, which is alkane. Now don't forget that alkanes, another sir, yes sir, we can say ester contain R prime. They will contain R prime now. All these people that have 2 R's, it does not mean that this R and R can be the same, and this R might be different from this R. So when this R is different from this R, they want to denote it with something different. They will now put R prime. Like this one now. This R can be CH3, this one can be CH3. But in case this one is CH3 and this one is C2H5, they will now put R prime. Do you get? They can be the same or they can be different. So the idea of prime is to show that this guy is different from this guy. Do you get that? So that's the idea. So the first JAMB question, I already said it. They are called paraffins. That's the first JAMB question. Sir, please don't be angry. I sent you the DM on TikTok. Yeah, that's not what we are talking here. Later, we'll check that one later. Please, let's focus. So paraffins, right? They mean little affinity. Okay, they mean little affinity. I already explained that. They have a general formula. General formula of CN H2N plus 2. This is the first JAMB question. CN H2N plus 2. This is the first JAMB question. What is the general formula of alkane? Now, don't forget, carbon is so unique. I mean, look at it. Carbon is so unique. Look at carbon. Carbon is so unique. Carbon can form bonds with itself. Who does that? That is a unique property. Carbon can form branch. This is a straight chain. Carbon can also form branch. Carbon is a unique being. Look at it. Carbon can even form bonds with other elements. Carbon can even form bonds with hydrogen. Carbon is so unique. Then this ability of carbon to form bonds with itself. This is another carbon. This is another carbon. This is another carbon. To form branch chain with itself, to form bonds with other elements is called catenation. JAMB question. Catenation. Catenation. This is a JAMB question. The ability of carbon to form bonds with itself and other elements. Are we good? Are we good? Catenation is a JAMB question. No? Ability of carbon to form bonds with itself and other elements. So Carbon can catenate. Carbon can catenate. Can catenate. Are we good? Are we good? Are we good? Please, let's be active. Are we good? Carbon can catenate. Are we good? Oh, carbon can catenate. No replies. Is it my network? Carbon can catenate. Yes, Olivia. Good. Screenshot if you want to. Now, but let me tell you something. Let me tell you something. It's not actually carbon only that can catenate. Actually, silicon is also in group 4. Not all group 4 can catenate, though, but silicon can also catenate. But the question you asked me, silicon can also catenate. What does the word mean? I told you. Ability of carbon. Please, you will come and listen to it later. Ability of carbon to form bonds with itself and other elements is called catenation. I even wrote it in words. Ability of carbon to form bonds with itself and other elements is called catenation. So now, silicon can also catenate. That is, silicon can form bonds with itself too. Silicon can form bonds with itself, and we call it silane. The bond form is called silane, just like alkane that we have been talking about. Alkane. So for silicon, it's called silane. But you guys will ask me a question. What's the question? Why don't we study silicon and its compound? That's the question you should ask next. If silicon can also catenate like carbon, the reason is simple. The compound formed by silicon are unstable. They are unstable. Hence we don't study silicon. We don't study silicon and its compound, because they form unstable compound. So we don't study silicon, but silicon can also catenate. Like carbon, but we don't study silicon and its compound because the compounds are not stable like the one carbon will form. Please take note of that. Silicon can also catenate. Now let's get back to work. These are what is important. Now I need to use a page. We'll now talk about something that you must know, and you will now see it. You will now see what I was saying the other time. Don't forget that the alkane, just like we said, they have CN H2N plus 2. Now that means if N equals to 1, they should, just like your firstborn. So in your family now, they want to give birth to your firstborn. So if N equals to 1 and you put it here, you realize that this is like saying C1 H2 into 1, because N is 1, plus 2. And what did you observe? So this is C2 plus 2, that's H4. Now, because the number of carbon is 1, the name must start with met. You must know this one. There's no way you can do organic. You don't know the prefix of these things. When the carbon is 1, it's called met, because you will need it when we talk about methanol, when we talk about methanoic acid. You know, you will need it. So why am I calling it 1? Because the number of carbon is 1. But now, which name will I add? This methane now is like you have a family and the firstborn name is Tosin. Now, if Tosin wants to introduce himself, he will say, I'm Tosin Ojo. Now, the Ojo that you add to Tosin is the surname. This is the surname or last name. Now, this is the first name of Ojo family. This is the firstborn. The same thing applies. Because the number of carbon here is 1, it's called met. So this met is the Tosin. Now, because it belongs to the Ojo family, because this guy now belongs to the alkane family, so this A must come as Ojo. So it will now come here. We call it methane. Methane. So that was how we got the first name. Methane. Methane. Okay. Now, if n equals to 2, still same general formula. So it will be C2 H2 into 2 plus 2. That means this is C2. 2 times 2 is what? 4. 4 plus 2, 6. H6. Same thing. Because the number of carbon is 2, it must start with 8. This is the second bond now of the alkane family. Now, because it belongs to the ane family, the last name, that's why you call this one ethane. Ethane. Are you with me? Are you guys with me? Because you must understand this basis. So, are you guys with me? Are you guys with me? Good. Now, if n equals to 3, same thing. Let's substitute it here. It becomes C3 H2 into 3 plus 2. So that means this is C3 H. 2 times 3 is 6. 6 plus 2 is what? Is 8. Now, because this carbon is 3, this is the third bond. We start it with probe. Now, because they belong to the ane family, we call it propane. Now, you know, there's a rule I said the other time. Sorry, not a rule. There's a property of organic chemistry I said that each successive member differ by dash CH2. Come and see it now. Let me pick this guy. Let me pick these two guys. Let me pick these two guys because they are successive. These two guys, because they are successive. Look at it. If I do C2 H6 minus CH4, I'm minusing it. What will you get? C2 minus C is ordinary C. H6 minus H4 is what? H2. So this is what they mean. That each successive member differ by dash CH2. Dash CH2. Now if this is a fluke, let's try another successive. These guys are successive. These guys are successive. This one, not this one and this one. It is successive like this, successive like this. Now let's do that's C3 H8 minus C2 H6. That will give you 3 minus 2, just C alone. 8 minus 6, that's what? H2. Can you see? Each successive, if that is a fluke, let's try another one. N equals to what? 4. Then you have, according to the general formula, C4 H2 into 4 plus 2. So from here you see that this is C4 H8 plus 2, that's H10. And this, because it is 4, we call it but. Now because it belongs to the family of ane, we call it butane. Now let's do if that is a fluke, let's do this guy and this guy again. So C4 H10 minus C3 H8. Can you see I'm picking successive members, not this one and this one. So can you see 4 minus 3 is what? C. 10 minus 8 is what? 2. Can you see each successive member differ by dash CH2? Do we get it now? Do we get? So that is a property that I said. And if you calculate the molecular mass, carbon is 12, hydrogen is 1. So 12 plus 2 times 1 is 14. So that is what we mean. Now, another JAMB question. The first alkane family. Now, don't forget, guys, this is the first bond, this is the second bond, this is the third bond, this is the fourth bond. So these bonds that we have here are what we call homologous series. Homologous series. I will not define what an homologous series is. But before that, let me just tell you that homologous series are members of a particular family, the alkane family, just like in this case, that have similar method of preparation and same physical properties. I will still explain that as we move on. But just know that your member in your family, all of you, you are an homologous series, okay? You are an homologous series. Just take note of that. Now, so as I said, JAMB question. Butane is the first member of alkane to undergo isomerism. We'll still do isomerism. So just take note. Butane is the first member to undergo isomerism. It's a JAMB question. Are you still with me, guys? Are you still with me? To undergo isomerism. Are you still with me? Are you still with me, guys? So first member of alkane to undergo isomerism is butane. This is a JAMB question. Butane, the C4. The C4. Are you guys still with me? Good, good. So let's move on. You can screenshot now. The C4. Good. Screenshot if you want to. Wait. Okay, now let's, this is C4. We can go on to 10. These are the common ones that they will ask you. So let's say C5 now. Don't forget the general formula is Cn H2n plus 2. So we are still using this. So for C5, 5 will come here. C5 H2, anywhere you see n, you put, this is when n equals to 5. So you put 5 plus 2. So you can see that this is C5. This is what? 10 plus 2, that's 12. Now, because it is, please, what is isomerism? We'll still get there. But just note that isomerism, we'll still get there, is the ability of a compound of the same molecular formula but different structural formula or structural orientation. Not structural formula, structural orientation. You will still get there, don't worry. Ability of same compound of the same molecular formula but different structural orientation. So you will still get there, but I just said it that butane is the first member because it's a question in JAMB. I just have to say it. I'm not supposed to mention it here, but I just have to say it because it's a question in JAMB. Okay, it's a JAMB question. That's why I have to say this statement. So your exam is fast approaching. It's not just teaching alone. Now pent, because it is 5, we call it just like pentagon. It's only this first 4 that will stress you because they don't follow the ideal. Met 1, et 2, probe 3, put 4. But from there now you'll be able to relate. Pentagon is 5. So pent, and because it belongs to the alkane, it's called pentane. When n is 6, you'll be able to relate to all this one. 6 H2 into 6 plus 2. That's 6 H14, right? Now because it is 6, we call it X. Now because it belongs to an alkane, right, we call it hexane. Yes, I love your teaching method. You know Zacchaeus now. You know how we roll now. You know how we roll. God has blessed us with this thing. You know how we roll. Even though if you have not heard it before, you will understand. Thank you so much. Okay, so now, just like when we insert C7, it is C7 H2 into 7 plus 2. So this is what? C7. 2 times 7 is what? Is 14. 14 plus 2 is what? 16. Now, because it is 7, we call it hept. Now, because it belongs to the A, it is heptane. Just like the heptagon that you guys are familiar with. As I said, it's only that one that will give you headache. When n is 8, the same thing happens. Put 8 here. C8 H2 into 8 plus 2. So from here, it is what? C8. 2 times 2, 16. 16 plus 2, 18. So from here, because it is 8, octagon, 8-sided shape, octane. When n is 9, it will be what? C9, just like you can see here, H2 into 9 plus 2. So from here, you can see that C9, 2 times 2 times 9, 18. 18 plus 2, that's 20. So this is what? non-argon. The last, not the last one, but for your level, this will be the last, because you can have undecaying, that's C11, but you don't need all of those things. They will not test you. So C10, just like you can see here, then H2 into 10 plus 2. So this becomes C10H22. So now because it is 10, just like your December decagon. So it's called decane. Nonane, octane, heptane, hexane, pent. So are we good? I hope you guys got up to this level. So these guys are the members that your family gave birth to. So they call them homologous series. 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 Let's reach. No, they will not teach you that one. You don't need it. I could say they will not teach you that one. It is important we talk about what they will ask you. We will not finish. It's not only organic chemistry that you need now. So now let's go. I want to talk about homologous series, so that I will define it for you so that you will know. But just like you can see, that means this is an homologous series. Just like you in your family, you are an homologous series of your family. I'm an homologous series of my family because I'm a member of my family. So if these guys are homologous series, I don't know why you guys cram this thing. I don't know. These are just homologous series. This is what they mean. So let's put it to chemistry terms. So we now say homologous series are, just like we say, you are members, just like you now and your sister, you are members of a particular hydrocarbon family or family with similar method of preparation and physical properties. Similar what? Method. That means if I can prepare methane, I can prepare ethane, I can prepare propane. That's what it's trying to say. That they have similar method of preparation. Just like all of you in your family, there's something so special about you. Your physical property might be the same, in quotes, and your method of preparation, your method of giving birth, just like your mom gave birth to all of you, might be the same. So that's what they mean. So members like propane, alkane, propane, ethane, they are all members of what? Alkane. So these are what we call homologous series. Okay, these are what we call homologous series. Now we'll now get into the right thing, and before that I must talk about what we call okay, which one should I talk about now? Anything balu must be balu. Okay, let's go. Let me talk about cracking. No, let me talk about method of preparation first before I talk about cracking, because you must know cracking. I will talk about cracking, then I'll talk about reactions, chemical reactions, right? Then we'll not talk about isomerism, then we'll talk about chemical properties. So let's go. Now, method of preparation, please. This one, method of preparation, because we want to confirm this thing, but I'll be saying some things that are very, very important. Method of preparation. Number one, you can prepare any hydrocarbon. Sorry. Don't forget we are dealing with alkane. No, we are dealing with alkane. So just follow through. Method of preparation. Reaction of sodium ethanoate with caustic soda, or what we call sodium hydroxide. Now most people don't know this thing, and it's funny. Now sodium ethanoate is just like ethanoate is an alkanoate, is CH3COONA. So we call this side first. So just like the way we name alkanoate, sodium, we call the alkanol part, but in this case sodium. The ethanoate. Why is it ethanoate? Et means two. You can see that carbon 1, carbon 2. So that's because the carbon here is 2, it's called earth. Now because it belongs to the alkanoate, it's called noate. Because of this sodium, it's called sodium. So plus sodium hydroxide is NaOH. So plus NaOH. Look at the magic that will happen. Please pay attention. If you don't pay attention, it will look like magic. It will look like magic. If you don't pay attention, it will look like magic. Now, we want to confirm this thing that we said here. Look at what will happen. Now, sodium, how many sodium do we have here? You can see that this is what I need. Because, look at it. Look at this guy. It will look like magic. Oh. Look at what I'm doing. That means I'll be left with H here, and I'll be left with CH3. Now, if this guy and this guy combine, let me just use the whole of this place. If this guy and this guy combine, you see that I've already formed hey, my pen finished. Oh my god. Oh my goodness. This is not it. This is not it. God. So this is, as I was saying, this is sodium. I'm not seeing it clear. Can you guys see it now? That is CH4, Abi. That is methane. If CH3 and H combine, that is what? Methane. That is what? Methane. Can you guys see it? Can you see it? I don't have this pen. Can you guys see it? Please, we explain the method of preparation, sir. I've not explained anything. I'm just saying when sodium ethanoate reacts with caustic soda, right? Which is sodium hydroxide, which is NaOH. Now this is sodium ethanoate, right? And this is NaOH, which is the caustic soda. Now, the only thing I want to do is that if you look at it, this is H, and if this H combined with this CH3, it will form CH4, right? It will form CH4. It will form CH4. It will form CH4. Then what is left is what I want to do now. Look at this. What is left? Look at this. Na. That's Na2. Then C, how many O? 1, 2, 3. So it will be left with what? Na2CO3. Na2, this pen now, which, yes, so Na2CO3. I hope this one works. So H4, good, it works. H4, and can you see that this is Na, which is, so this is CH4, then this is Na2, because this is Na2, Na is Na2, then this is C. Then how many oxygen do you have? 1, 2, 3. CO3. So can you see that we've already formed one member, which is what? Methane. Now the question now becomes, come collect pen. What are you saying? Now, I've seen another one. I have to go buy a bunch of pen, right? Thank God I have to see another one. I want to destroy our plan. Now, methane, Abi, can you see? Now the question is, because you know I said something. These homologous, they have similar method of preparation. Now the question you should be asking me that, should you have formed methane? We are going to form ethane now. Go and form the second member now. I will form it. I will surprise you. Now screenshot. If you want to screenshot, don't forget this thing we are doing. I just bring this NaO to this guy, then I form Na2CO3. Then what is left is this and this, and I form methane. Now, so your question will be, if you have screenshotted, let's move. Now let's see if it is possible to form the second member. Let's see if it is possible to form the second member. Now look at what will happen. Now look at, this is sodium ethanoate. So what I will just need to react is reacting sodium propanoate with NaOH. You see, that's all. Now look at it. Sodium propanoate is CH3, CH2, COO, Na. Why is it prop? Prop means when the carbon is 3. I taught you. So 1, 2, 3. That's why the carbon is, that's why it's propanoate. How is it no 8? It's because of this alkanoate group. Then sodium plus NaOH. That is the rule. Now look at what will happen. Same thing we did. Makes sense now. Thank you so much, sir. You are blessed. You are blessed. Now look at it. Oh yeah, look at the same thing that we did. Then what is left? CH3, CH2, then the H here. Can you see? CH3, CH3 plus Na2, then COO3, which is CO3. So is this not ethane? Is this not ethane? Have I not formed the second member? Some people will be like, they are not satisfied. Let's go and form the third member. What will I use? I will use sodium butanoate. That's what I will use. How come the other CH3? Can't you see CH3, CH2? Add H to it now. It becomes CH3, CH3. This one is CH3 plus H, so CH4. Then I'm still going to form my Na2CO3. I still form my Na2CO3. Just put H to this. It becomes 3 now. Good. Sodium butanoate plus sodium hydroxide. Because some of you did not believe that statement when I said they have similar method of preparation. Now, but there's something special though, but just follow me through. Now, look at it. That will be, butanoate to be CH3, CH3, CH2, COO, Na. Why is but is 4? 1, 2, 3, 4. So sodium butanoate plus NaOH. Yeah, look at it. I just need to form my Na2CO3. Then my H will come and combine with this. That will be CH3, CH3, CH3. Because this is 2, then H will come here and form CH3. So this is what we call propane plus Na2, because the Na is 2, C, then oxygen 1, 2, 3, CO3. So can you see that I formed the third member? So they have similar method of preparation. See, I can form up to decade, but that's not why we are here. We just have to understand that they can be prepared similar. But this, don't forget that this first one is for, you can use it for everything. Like, just like, I don't understand which side. You just joined or what? Do you just join? Well, you can watch it again after the live, but this is so easy. I've used all everything to explain this. It's so easy. Just follow through. Propanoate, because I want to form ethane. Butanoate, so it must be 1 carbon ahead of the propane. The other alkane you want to form. Just like this one, prop, I'm forming ethanoate. When I wanted to form methane, I was using ethanoate. 2 carbons. Can you see? Because do you know why it must be like that? Because this Na2CO3, it has already carried 1 carbon. Can you see? It has already carried 1. So I must be a step ahead to form the one below me. So because this Na2CO3 has already carried 1 carbon. It's so easy. Organic chemistry is interesting. I had 93 in my, is it 93 or 94 in my organic chemistry in 100 level. But sodium must be used. Yes, now it is forming Na2CO3 now. You don't need it. It's not part of organic compound. So for the butane, it will be, why will it be sodium propanoate? Why will it be soda? It will be sodium pentanoate now to form butane. It will be sodium pentanoate to form sodium butanoate is already forming propane now. Sodium butanoate is already forming propane. So if you want to form butane, it will be sodium pentanoate. It must be a step ahead. Penta means the 5, carbon is 5. Because Na2CO3 will carry 1 carbon. Do you get that? So if you, okay, let me just do it so that you understand. So look at it, sodium pentanoate plus NaOH. Exactly. So sodium pentanoate is CH3, 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 COOH plus NaOH. So this is sodium pentanoate. Now, don't forget the rule. This guy will carry this guy. We carry this guy. Then this H will come and join this guy. So when this H come here, then 1, 2, 3, 4. Can you see that? Sorry, this will be 2. So please confirm the molecular formula for the propane. Propane C2. What am I writing like this? I think there's a mistake here. Propane should be C. That's H8, Abby. I'm coming. What is it? Propane is 8. Sorry, I think propane is CH3. This should be 2. Sorry. I think this one should be H then. It's because I'm right. This is a condensed form. Thank you. This is a condensed form. Sorry, this is correct. This is correct. So butane now will be C4H10. So let's confirm. So this will be C 1, 2, 3, 9. So this one will be C like that. This will be C. So that when H comes here, it will come 3 plus 3 plus 3, 9. 9 plus 1, 10. So thank you. It's because I'm writing it in a condensed form. So this is butane. We use 5 carbon to form. Good. That's the word. So please take note of this. This one is correct. Ethane is C2H6. So it will be this. Okay. That's one method of preparation. Number 2. This one is a JAMB question. The number 2 I want to teach you is a JAMB question. Number 2, we are on that method of preparation. Oh, I love your teaching, sir. God bless. That's why we are the best, man. Okay, I love your teaching. Thank you. Now, number 2. Number 2 is when aluminium carbide dissolves in water. Now, this is a JAMB question. This can only form methane. I will even put only again because it's a JAMB question. Only. That means you cannot use this one to prepare all of them, unlike that first method. So when aluminum carbide dissolves in water, it is the only product you will find is methane, not ethane, because it's a single product. So what do I mean? Al4C3, when it dissolves in water, H2O. So this guy will just form CH4, which is methane, plus AlOH bracket 3, aluminum hydroxide. So the only product that this guy will form, that means this one is specifically for methane. Aluminum carbide dissolving in water is specifically for what? This aluminum carbide, this is water, sodium hydroxide, then methane. So when aluminum carbide dissolves in water, is specifically for what? Methane. Aluminum carbide in water is specifically for what? Methane. I know I did repeat that, but this one is not for everything. It's only for methane. So, are we good? Do we get it? Aluminum carbide in water is only for methane. Are we good? Good. Balance the equation, sir. You don't need to balance it. You don't need to balance it, but you want me to balance it. This will be 3. I'm coming. You don't need to balance it. Just forget about the balance. Don't worry. You don't need to balance it. That will delay our time. Just this. You don't need to balance it to just know that these are the products. That will delay our time. Cannot be balancing equation now. You don't need to balance it. Just leave it. These are the products. Cannot be using now to be balancing something that will not. They will not ask you to do. Number 3. There's no time. Number 3, just know that it is methane that this aluminum carbide is for. Okay. Number 3 is Grignard reagent. We can form this guy with Grignard reagent in water. Now this one too is for everything. It's not like this. This one is just a special guy that loves methane. So Grignard, can you explain again? When aluminum carbide, this aluminum carbide, right? When aluminum carbide dissolves in water, this can only form methane only. The other methods that can form all members of alkane, we've already explained that, but this one is only for methane. It cannot form ethane, it cannot form propane, it is only for methane. So this is aluminum carbide, and this is water. So it forms methane and aluminum hydroxide, AlOH bracket 3. So that is that. Now, Grignard reagent, if you are going to OAU, you must know this. RMGX. This is the general formula, where X is an halogen. If you are going to OAU, you must know what the general form of Grignard reagent. X is an halogen, then R is an alkyl group. Alkyl group. So this is a very common question in OAU post-UTME. That's what I'm trying to say. If you are going to OAU, you must know it. So now, if this guy dissolves in water, look at what will happen. Let's say I pick the first methyl, which is methyl is the first alkyl group, CH3, Mg, right? Then X. Now, in this case, I want to use Cl. You know, I said it's an halogen. Chlorine is an halogen, right? Then, let's say it dissolves in water. Look at it, oh. Please pay attention, right? Now, my goal is simple. My goal is I'm forming alkane. It's the method of preparation for alkane. That means I just need to remove one H here to put it to this guy so that I can form CH4. So when I bring one H and I put it to this guy and form CH4, what will be left in H2O? If I remove H from H2O, what will be left here? You know, don't forget that this guy is just H plus OH. So I've already removed H and put it there to form CH4, which is the first methane, which is the first member I want to form. Now that means OH will now come here plus Mg OH Cl. Good. So these are the products. So methane and a basic salt. This guy, please take note. This is a basic salt. Just take note of that because it has OH. If it is acidic, it will have H plus. I just want to say it because of your exam. So this is a basic salt. It has OH inside. I'm on my network. Oh, hey, sorry, you come out. You come back to watch it. So OAU post-UTME, you must know. Even though UI, you must know Grignard reagent. So I'm lost from number 3. Please, if it is by network, don't let me repeat it again. If it's by network, you can come back again, but I'll just repeat it now. So Grignard reagent in water, we can use to form all alkanes, any member. So what is the general formula for Grignard? It is RMGX, where X is an halogen, group 7 element, and R is an alkyl group. That's what I said here. R is an alkyl group. So I now use and I represent them with not R and X and put something there. I've started again now. I've started again. So please, my network is not good here. You can check back. I will leave it. I will make it so that you can check it. So R is an alkyl group. Look at it. Then Mg. Then I represent X with chlorine, which is the halogen I prefer to choose. Then dissolving in water, right? So when I dissolve in water, and I told you that my goal is to form an alkane. So this is the first alkane I'm forming because it is H and OH. So this H will just come here. So I have CH4. Then what is left? MgCl. So the MgCl will combine with OH. It will now form MgOH and Cl. And I told you that this is a basic salt because of JAMB, because it has OH. Anything that has OH, any salt that has OH is a basic salt. Any salt that has H is an acidic salt. So this is a basic salt because it has OH. Okay, if you don't understand this, let me pick another Grignard reagent and form another alkane. Let's say, look at it. Let me pick CH3, CH2, MgCl. Don't forget, that is RMgX. So the alkyl group I'm picking here is an ethyl. This is an ethyl. Why is it ethyl? It has 2 carbon, right? And it belongs to an alkyl group. Because there's a general formula for an alkyl. The general formula for an alkyl group, please take note of that. The general formula for an alkyl, the general formula is CnH2n plus 1. This is alkyl, not alkane. This is general formula for alkyl. So that's what we are doing. So when n is 2, we put it here 2. C2, H2 into 2 plus 1. So it will C2, H5. 2 plus 2. 2 times 2 is 4. 2 times 2 is 4. Then 4 plus 1 is 5. So that's why this is C2, H5. So plus, we already said it's dissolving in water. And I told you that water is H and OH. So the H, the function of this H is to complete this guy such that we can have CH3, CH2 plus 1, CH3. Don't forget, I will have what? Mg, OH that is left, OH, then Cl. So if you can see this, this is what? Ethane. Second member. Exactly, John. Exactly. Now, if you are not still comfortable, let's pick another one. Let's pick the next member, which is when n is 3. Do it. When n is 3, you have C3, 2 times 3 plus 2 times 3 is 6. 6 plus 1, H7. C3, H7, H7, Abi. Then what do you have? Mg, because this is what? This is propyl. Where are you lost? You are lost. You are not following here. Because I broke it down. Where are you lost to? Well, you can come back to check it, Sean. Your network is bad because you are not even talking. Okay, so let's continue. So propyl, then Mg, it's enough Cl plus H2O. And don't forget, this H2O is H and OH. So the H is to come here so that it can form. Sure, Jennifer, it will be there, So it will be C3, 7 plus 1, which is what? H8 plus Mg, OH, Cl. So you can see this is what? Propane. So we can form as many as possible. So that is the second method of third method of preparation that we formed here. Yes, that's the third method. So let's go. We can also decarbosylate. So the fourth method is decarbosylation reaction. Look at it. Decarbonization means we are removing CO2. Decarbonization of an alkanoic acid. Exactly. Not OH2O. It is MgOH and Cl. Alkanoic acid. Look at what will happen. Decarbonization. We want to remove what? We want to remove CO2. That's decarbo. We remove. So let's see. If I have CH3, COOH. Let's say we decarbonate when we remove CO2. This is CO2. We have removed CO2. What is left? CH3 plus H. So I can form methane. I can form methane. If we decarbonate. Decarbonate just remove, you are removing CO2. Can you see CO2Os? So we are removing CO2. So what is left is CH3 plus H, which is CH4. Now, if that is not clear, let's pick another one. Let's say I want to decarbonate C3H7COO. I will form methane, yes. H. Now, let's say we want to decarbonate. That means we want to remove CO2. And this is CO2 here. So can you see when you remove CO2, what do you have? C3. H becomes 7 plus 1. H8. This is propane. Can you see that all of them are having similar method, except that aluminum carbide that is specifically for methane. Let's say I want to pick C4H9 COOH. Just remove, decarbonate it, which means I'm removing CO2. What do I have left? C4H9 plus 1 H10. Is this the decarbonation of ethane? Yes. Yes. Joy Annie, are you lagging? I've said 93 since now. I think you are lagging behind though. So this is butane. We are not where we are now. This is butane. So this is. Are you guys on this page? Are you guys on the same page with me? Are you guys on the same page with me? Are you guys on the same page? Yes. So we can go on and on. Butane will be formed, exactly. Are you guys still with me? Are you guys on the same page? Are you guys on the same page? Sir, you are good. Yay, Fafure said you are good. Bless up, bless up, bless up. Thank you, thank you. Thank you. It is a gift. You don't learn it, you earn it. Yeah. Come, can someone say So I just learned something. Yes, you just have to keep learning, man. You just have to keep learning. You just have to keep learning. Well, the last method, I think, wait, is that number 5th? Yes, the 5th method, which is the last method, is that alkane or alloalkanes can react with sodium to form alkanes. Alkanes can react. Look at it. Halogens, then alkanes. So e.g., look at what I will do here. CH3Cl is an alloalkane because this is an halogen, then this is an alkane. So plus what? Sodium. I'm coming now. CH3Cl. Is it sodium or sodium hydroxide? I'm coming. I think it must be sodium hydroxide. NaOH. NaOH, yeah. Please, we explain number 4. Decarbonization, you are removing CO2. CO2, this is CO2 now. Just remove it. What is left is C4H9 plus 1. C10 now. No, this one is simple. Just remove. This is CO2 now. Is it not O2? The oxygen here is 2. CO2. Remove it. Decarboxylation. It's not hard now. Sir, please, remove our CO2 is called decarboxylation. Decarboxylation. No, you will come back to it, please. With Na, it would form NaCl. Yes, that's what I'm saying. It will form NaCl, but I need to complement it with H, so that's why I have to change this to NaOH. Do you get? This is another rocket science. Look at it. If you do not change it, it will be CH3Cl plus Na. Am I not? Yes. So in this case now, it will now be just like you said, it will be NaCl. Then what happens? Where is this? When we complement this one to make it an alkane, so that's why I changed it to this. Do you understand? So NaCl, right, plus water, then plus what? Don't forget that this H will now come here to now form the CH4. Sir, CO are the esters, right? Yes, R, COOR, they are the esters. RCOOH, they are the acids, alkanoic acid. I already explained this one, so you can come back to watch it though. These are alkanoids, these are alkanoic acid. Yes, now this is alloalkanes now. This is alloalkanes. This is halogen. These alkanes, they call them alloalkanes. I did not make mistake. So this is alkanoic acid. Then this alkanoate. This is alkanoic acid, COOH. Then RCOOR. This number 5, they don't really ask it like that, but I just want to teach you. So I will now go to cracking. Then after cracking, I will talk about isomerism. Then I will talk about chemical properties. So we are done. Understood. Good. We are done with alkane like that. Hopefully, yes. I think maybe because it's almost 9, so that we can miss. So another example. Okay, let's say we have CH3, CH2, Cl plus NaOH. Same thing, NaCl plus H2O. Then H, my job is to find an H that will combine with this one, so that it will form CH3, CH3. So this will now be what? Ethane. I can go on and on. I can say C2H7, Cl. Sorry, C3H7, Cl. This is number 7 that I'm doing again. This is number 7. There's no time to be giving you one. You can have your past question and do it. So C3H7Cl, right? This is another. I'm picking different alloalkanes. So this is for ethane, chloroethane. This is chloropropane. I'm picking different alloalkanes. Then NOH. You see that this one will form NaCl plus H2O plus. My job is to make this H come and meet this guy. So I'll form C3H8, and this is propane. It's so easy. I can go on and and make it happen. The same thing, we have C4H9. Same thing, Cl plus NaOH. My job is to make this H come here. Then Cl and OH will now form something. What will they form? NaCl, H2O. Then H combined with this is C4H10, which is butane. I can go on and on. This thing is patterns. Organic chemistry are patterns. Once you recognize the pattern, you are good to go. Okay. So Are we good to go? Good to go, good to go, good to go. Then I want to teach you cracking. I want to teach you cracking. Yeah, I think you need cracking and some very good questions like octane rating. Yeah, octane rating. So let's go. Then we'll now talk about isomerism. So now let's talk about cracking. Please, I was in a place yesterday and they don't understand, they don't know the difference between cracking and reforming. And I will teach you now. So how will I be able to watch like later? You watch it, you see it. You will see it. Don't worry, you watch it. You will see it. I will name it Organic Chemistry 1, Alkane. You will see it. So cracking. What is cracking? Cracking, just like the name, is the breaking. I didn't ask you to mention anybody. I didn't mention anybody. I said there was a controversial, and I will tell you. Cracking, please delete this statement here. I'm not asking you to mention anybody. Now, cracking is the breaking down of larger hydrocarbon. I did not say organic compound though. Larger hydrocarbon. That means I'm just talking about anything that contains hydrogen and carbon. Larger hydrocarbon to form a smaller hydrocarbon. The smaller hydrocarbon are usually alkane, and hydrogen. So that is what cracking is. So when we have something like maybe C12 H26, when this guy undergo cracking, it can begin to form an alkane. It can form an alkane. It can now liberate hydrogen gas with it. So this is larger hydrocarbon forming an alkane. The alkane can be something like, let's say 66H, 12, that's H24. Then the alkane can be 66H 2 times, that's H12. What am I saying? No. It cannot be 66 like this. Sorry. I made a mistake. 24, okay, 24 times 2 is what? Is, okay, 12 times 2 is 24. 24 plus 2, yeah, it's correct. Not this. Please just take note of, it can form an alkane. Okay, just take note of that. I don't want to make it complex. Now, there are two types. There are two types of cracking. There's catalytic cracking and thermal. Are kind of smaller. No, they don't usually form alkynes. Yes, they are smaller hydrocarbons, but they don't usually form them. They are majorly alkanes and hydrogen. And thermal, there are two types of cracking. Types of cracking. Catalytic, and the catalyst here is zeolite. That's what I want you to know. Zeolite catalyst, that's what is used. And it will be at 500 degrees Celsius. But if you are using thermal, just like the name, it will be at 800 degrees Celsius. So if you do this thing under catalytic, you use zeolite catalyst under 500 degrees Celsius. Oh, Chim, my village people. Sorry, you can come check it later. But if it is thermal cracking, it will be temperature of 800 degrees Celsius. 800 degrees Celsius. We are running out of time, so you have to be fast now. But just take note of that. Now, what is now reforming? What is reforming? What is reforming? That's, the cracking is breaking down like this, right? Cracking is breaking down. But reforming is the conversion. This is a JAMB question of straight chain hydrocarbon into branched chain hydrocarbon. There's a purpose for doing this, to improve. Yes, that's why they call it thermal now. It doesn't have catalyst. It's just that it must occur at a higher temperature than this. And they gave you catalytic and thermal. Thermal cannot have catalyst now. That one is common thing. So to improve the quality of the petrol, to improve the quality, it can be cyclic. That's why it says to branch chain. The branch chain can be branched, it can be cyclic, it can be just be branched. So what am I trying to say? E.g., let me give you an instance. You can have something like this. Can you see? This is a straight chain. If a petrol is solely like straight chain like this, the octane rating is low. But we can have this thing being converted to something like this. 1, 2, 3, 4, 5. Can you see? So this is branch chain. So this is what they call reforming. Conversion of straight chain into branch chain, so that you can improve the quality of the petrol. Is called this process you are seeing here is called reforming. So please don't forget this. Reforming is where from cracking. You can see that we are not breaking anything down here. We are only converting. Okay, please take note. It's a JAMB question. Now that brings us to the concept of octane rating. But the question I want to ask you here is that N-heptane, this is a JAMB question, just take note as I want to say, has an octane rating of 0. See, most of you will be asking question. I just note it too. Of course, N-heptane is carbon. The carbon is 7 and it's an heptane, and it's a straight chain. That's why they call it normal heptane. N here means normal heptane. So it has an octane rating of 0. That is so low, because you already said it. It's when you convert this straight chain to branch chain that you improve the quality. Now, but this guy, which is called 2,2,4-trimethyl-pentane, it has an octane rating. Octane rating is talking about the performance of a petrol. It has an octane rating of 100, because this one is branched. Sometimes they'll call it, if they don't put this thing, they call it, it's also an N-octane. Why is it octane? Because the methyl here, the methyl is 3. So 3 carbon, then 5 carbon. So 3 plus 5 is 8. So they call it N-octane. So the octane rating of 2,2,4-trimethylpentane, it has an octane rating of 100. That's a JAMB question. It has an octane rating of 100. That's a JAMB question. It has an octane rating of 100. Why N-heptane has an octane rating of, 0? Please, do you guys get it now? Do you guys get it up to this point? Before I go to isomerism, good. Then we now talk about chemical properties. Then we talk about maybe name. We will talk about naming. Good. There's no time, so please take note of that. This is a JAMB question. No, this one is a JAMB question. You understand? It's a JAMB question. So another thing you want to know is send the paper well. So send the paper so I can screenshot it. Is it not well like this? Sorry, give me screenshot. I don't know if it's not well like this. So I don't know what to mean by well. So have you done that? Juliet, have you screenshotted? Have you screenshotted? It is not, the comment is covering it. Check. Can you screenshot now?
Rosan.
How can they structure the question? I already told you now that this, which one has an octane rating? You know, it's branched, so the quality is better. I already told you. So, which of these has a better octane rating? They will now put these options. Okay, so remove the comment section.
Rosan.
Remove comment section.
Rosan.
I'm coming. Can't you screenshot now? Can't you screenshot by placing it like this? You can't screenshot it like this. Oh yeah, screenshot. If I removed it now, you guys are not screenshot, so I want to take it back. Good.
Rosan.
So now.
Rosan.
Come on. Okay. So let's continue. So let's get to what's it called? Okay, before I get to naming, okay, I think I have to talk about naming first before I get to isomerism, then chemical properties, and we are good to go. So now you must understand naming. Most of you don't know naming. Naming of alkanes. Then we'll now go to isomerism, then chemical properties. Sir, can you please draw that compound? Which compound again? You know? Yes, we are going to name it now. You will see it. You will see it. Now, please, this stuff is easy. So just pay attention. We have just 15 minutes to round off these sections and we are done with our alkanes. Now, naming. What do I mean by naming? Look at it. If I have methane, simple. Just this H. That's methane. If I have, this is CH4. So if I have C2H6, simple, 2 carbon. How many hydrogen? 6. Because they are saturated. And I already told you that carbon must always have 4. 1, 2, 3, 4. Always. You can use it to teach others. So you can use the trick to teach others. So you can teach it on the other anywhere. So now H. So how many carbon? How many? 1, 2, 3, 4. 1, 2, 3, 4. Okay. Now if it is, I'm just trying to draw random stuff. Let's say C3H8. So you realize that just be adding CH2 to this, you get this. Add CH2 to this, you get it. You already said they differ by that. So I mean that means the carbon here is 1, 2, 3. Abi. How many hydrogen? There must be 8 hydrogen. Let's count. 1, 2, 3, 4, 5, 6, 7, 8. Easy, Abi. All this one are still easy. We'll now be talking about, I will now give you the rules. C4H10, still same thing. Abi. So you see that, you see this, you see this. You see. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So easy, Abi. Now, of course, you should know that this is what, because it's 4, it is butane. Don't forget we are naming alkane. No? This one is what? Is propane. Then this one is what? Is ethane. And this one is what? Is methane. Okay. Now, that is straight chains. They are branch chain as well. 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 Now, look at it. Let's say we have something like this. Now, look at it. This is where the rules now comes in. This is where the rules now comes in. But before we go to branch chain, let me just teach you cyclic one. Now, look at this. 1, 2, 3, 4. That means, don't forget, the carbon must always have 4. And here it's just 1, 2. That means carbon must have 1, 2. So that you can make it 4. Carbon here is just 2. So carbon must have 1, H, 2. Carbon here is just 2, 1, 2. But it must have 4, H, H. Now, because it is cyclo, and the number of carbon is 3. 1, 2, 3. So we call it cyclo. When the carbon is 3, what do we call it? Cyclopropane. Okay. Now, let's do another one. It can be anyhow. You just have to be smart with what the carbon here must have 4, and it just have 1 and 2. That means there must be hydrogen, hydrogen. That was the first statement I made. Oh, those that joined it. That was the first statement I made. Oh, where did I even put it? Paraffin, where did I put it? Oh, that was the first statement I made. Can you see? That was the first statement I made. If you join late, that's where. So if you, in fact, if you have not, you should watch it again so that, can you see? So they are called paraffins. Those are the first statement I made. So now look at it. It's cyclic. Because it's cyclic. And how many carbon do we have? 1, 2, 3, 4. So it's called cyclobutane. That's the way we named this. Because they are cyclic. So they can ask you anyway. Let me do the last cyclic. Look at this. 1. It can be any way. I'm just trying to give you different ways. Look at it. The way you must know that carbon must always have 4 to it. Always. It is a must. Always have 4. Now, how many is here? It's just 2. 1, 2. So it must be 4. H, H. 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 Now, because it is all 4 now, and it is cyclic, but the number of carbon is 1, 2, 3, 4, 5, 6. So this is cyclohexane, because the number of carbon, oh, I just joined. Yeah, cyclohexane. Now, do you understand all this cyclo? Cyclo because it is cyclic, and the number of carbon 1, 2, 3. Cyclobutane 1, 2, 3, 4. Cyclopropane 1, 2, 3, 4, 5, 6. Cyclohexane. Do you understand this before I move to branched? Branch is the major thing, but all this knowledge are now very important. Oh yeah, let me see if you guys understand. Yeah, you guys should name this. Do you guys understand though? If you are not talking, it shows. You guys should name this. Okay, good. You guys should name this. Just have to be smart. These stuff are not hard. Yeah, name this. What will be the name of this? Be fast so that way. Cyclopentane. Okay. Then we'll now go to branched. Branched is the major thing. Then I'll give you the rule. Once you know the rule, you are good to go. Say your answer, not what is the answer of this one. What is yes, sir? What is the answer of this one? That's what I'm asking you. What's the answer? We should be done in a few minutes. So, well, that's why I don't want to give question, because it's recorded. So time. So because sir, what about does it in a triangular shape? Are you not here since this triangle now? Don't draw us back. This triangle. Can't you see this triangle? This is rectangle. This, there are different shapes I've been drawing. This triangle, this is it now. I've been drawing it. Please pay attention. Because 1, 2, 3, 4, 5. Because the number of carbon is 5. So it's with cyclopentane. Pent 5. Cyclopentane. Now branched. This is where the major mate is. Now look at it. 1, 2, 3, 4. Then let's say I have CH3 here. Then this is where the rules is